there, curious minds. Have you ever thought about how computers store and process information? What if we could literally see the ones and zeros that run everything? Binary digits. That first, let's get the setup ready. We have 6 LEDs connected to an Arduino. These LEDs will represent the 6 bits in a binary number. If you remember, binary numbers are made up of just 2 digits, ones and zeros. Each LED here will be controlled by a bit in a binary sequence. In binary, each position represents a power of 2. So let's start with the basics. When we want to count, we move from 0 to 1, then 2, 3, and so on. But instead of decimal digits like 0 to 9, binary uses just ones and zeros. Each bit can either be 0 off and 1 on, like our LEDs here. Now let's get into something really cool. ASCII. Every letter or character you type on the keyboard gets converted into a binary number. For example, the letter A is represented as the binary number 01 000 001. See how each bit controls an LED on the board? So when you type A, this is what happens behind the scenes. Okay, let's dive into the code behind this. Here's the part where we tell Arduino what to do. Each pin corresponds to one of the LEDs in our circuit. This line, int pin 1, 8 is equals to 8, tells the Arduino that pin 8 is controlled by the first LED. Similarly, pin 2 controls the second LED and so on. Then in the setup function, we set all the pins as output because we want to turn the LEDs on or off. Now let's look at the main part of the code, the loop function. Here's where the magic happens over and over. Each time we change the LED states, we're essentially writing a binary number. Pin controls highlight how each digital write pin, high or low, command controls the LEDs. For example, this line, digital write pin 1 high, turns on the first LED, while digital write pin 2 low keeps the second one off. By changing these states, we are counting in binary, one step at a time. Watch as we go through all the possible binary numbers using our 6 LEDs, starting from 000000, where all the LEDs are off, to 111111, where all the LEDs are on. This is binary counting in action, and this is exactly how computers process numbers, letters, and even images. Now let's talk about the most significant bit, MSB, and the least significant bit, LSB. The MSB is the first bit on the left and the most important in terms of value. The LSB is the bit on the far right. These bits determine the overall value of the binary number. So why is binary so important? Well, all your devices from smartphones to computers rely on binary to process information. Every time you send a message, open an app, or play a game, it's all happening because of binary. And now you know how it works.